everyone, this is your Kalpana here. So in this video we are going to see a problem from exponential series. So let's get started. Problem: find the sum of the series 1 plus 2 square by 1 factorial plus 3 square by 2 factorial plus 4 square by 3 factorial plus so on. Solution: so we are given a series 1 plus 2 square by 1 factorial plus 3 square by 2 factorial plus 4 square by 3 factorial plus so on. So here we have to find the sum of these series. Okay. So we are given series 1 plus 2 square by 1 factorial plus 3 square by 2 factorial plus 4 square by 3 factorial plus so on. Okay. Here we are having 4 terms. In that, first terms looks odd while comparing to the other terms. So what we'll do is we'll change this 1 as 1 square by 0 factorial. Since 1 square equals to 1 and 0 factorial equals to 1, we'll get 1 square by 0 factorial equals to 1 by 1, which is equals to 1. So here you can replace 1 by 1 square by 0 factorial. Okay, 1 square by 0 factorial, and write the remaining terms as it is. So here you're having plus so on. We don't know where it ends. And the number in the denominator 0 is less than the number in the numerator 1. Okay, here also you have the number in the denominator is less than the number in the numerator. 2 is less than 3, 3 is less than 4. So we'll write in general n square by n minus 1 factorial. Okay, n minus 1 factorial. The number in the denominator is less than the number n in the numerator. Okay, fine. So for n equals to 1, why we are writing n equals to 1 here? From 1 is, you're having n minus 1 factorial, right? If we take n values from 1, you'll have 1 minus 1, 2 minus 1, 3 minus 1. 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2. So you'll get positive numbers. Okay. If we take n equals to 0, you'll get minus 1. Since in order to neglect the complexity of the problem, we'll just take from n equals to 1. Okay. And it goes on, right? So we'll take infinity. Fine. So if we substitute from n equals to 1 to infinity, we'll get these terms. Let's check it for n equals to 1. If you put n equals to 1, in this expression you'll have 1 square by 1 minus 1 factorial, which is equals to 1 square by 1 minus 1 is 0 factorial, right? Which is our first term. So if you substitute n equals to 1, you'll get the first term. And for n equals to 2, 2 square by 2 minus 1 factorial equals to 2 square by 2 minus 1 is 1 factorial. We got the second term. Likewise, we'll check for 3 and 4. For n equals to 3, 3 square by 3 minus 1 factorial equals to 3 square by 3 minus 1 is 2 factorial. Third term. For n equals to 4, we'll get the fourth term. Okay, fine. So the expression, the summation term is correct. Fine. In the denominator we are having n minus 1 factorial, but in the numerator you have n square. Since we know that n factorial equals to 1 into 2 into 3 into so on into n minus 2 into n minus 1 into n. Okay, likewise, we have n minus 1 factorial equals to from 1 to n minus 1, right? 1 into 2 into 3 into so on into n minus 2 into n minus 1. But we are having n square in the numerator, so we'll change this n square in terms of n minus 1. Since we are having n minus 1 factorial in the denominator. Okay, fine. So we'll take n square as dividend. Take n square as dividend and n minus 1 as divisor. So we have to multiply with this some number with this n minus 1, so that we'll get n square. Okay, so n minus 1 into, we need to get n square. Okay, keep in mind that we need to get n square. So I'll take the last two numbers, n minus 1 into n minus 2 will be n into n square minus 2 into n, 2n minus 1 into n, and minus into minus plus 2 into 1, 2. So this equals to n square minus 2n minus n is minus 3n plus 2. So n minus 1 into n minus 2 is n square minus 3n plus 2. Now change the signs. See here. Now we'll cancel plus n square and minus n square. Fine. We'll get 3n minus 2. Here again you're having n term. So in order to cancel this, we'll again use n minus 1. N minus 1. Here you're having 3. So multiply it with 3. So this is equals to 3n minus 3. Okay, here you're having plus. So put plus. 3n minus 1 into 3 is 3n minus 3. Now change the signs. Plus 3n minus 3n gets cancelled. Plus 3 minus 2 is plus 1. So here we don't have any n terms. So we can't proceed further. We'll stop it here. Okay. So we have a formula. The dividend equals to divisor into quotient plus remainder. Okay, if we multiply the divisor with quotient and finally if we add with remainder, then we have to get dividend n square. Let's check whether we are getting it or not. So divisor into quotient. Divisor is n minus 1 into quotient n minus 2 plus 3 plus remainder plus 1 is equals to n minus 1 into n minus 2 plus 3 into n minus 1 plus 1, which is equals to, we are having n minus 1 into n minus 2 is n square minus 3n plus 2 plus 3 into n minus 1 is 3n minus 3 plus 1. So here you can cancel minus 3n and plus 3n. Plus 2 plus 1 is plus 3. And you're having minus 3. Better we can write in the next step. Plus 2 plus 1 is plus 3 minus 3. Here also we can cancel. Equals to n square, which is our dividend. Okay, so we have used this formula. And we have n square equals to n minus 1 into n minus 2 plus 3 plus 1, which is n minus 1 into n minus 2 plus 3 into n minus 1 plus 1. So we are having, since n square equals to n minus 1 into n minus 2 plus 3 plus 1 which is equals to n minus 1 into n minus 2 plus 3 into n minus 1 plus 1. So now what we'll do, we'll just replace n square by this. Okay. So this becomes summation n equals to 1 to infinity. Now replace n square by this term, n minus 1, this expression. Okay. N minus 2 plus 3 into n minus 1 plus 1 by n minus 1 factorial. Since we are having 3 terms in the numerator and 1 term in the denominator, so we can split this total expression in 3 terms or 3 fractions. I can say this equals to 1, n equals to 1 to infinity, n minus 1 into n minus 2 by n minus 1 factorial plus 3 into n minus 1 by n minus 1 factorial plus 1 by n minus 1 factorial. Okay. So you would write it as summation n equals to 1 to infinity n minus 1 into n minus 2 by n minus 1 factorial plus summation n equals to 1 to infinity 3 into n minus 1 by n minus 1 factorial plus summation n equals to 1 to infinity 1 by n minus 1 factorial. So this becomes equals to summation. We'll write the numerator as it is. In the next step, we are going to cancel it. Okay. Fine. N equals to, since we are having n minus 1 factorial in the denominator, we have n minus 1 factorial equals to 1 into 2 into 3 into so on into n minus 3 into n minus 2 into n minus 1. Also we have n minus 3 factorial equals to 1 into 2 into 3 into so on into n minus 3. Okay. So here we are having 1 into 2 into so on into n minus 3. So we can replace it by n minus 3 factorial. Okay. So we'll get n minus 1 factorial equals to n minus 3 factorial into n minus 2 into n minus 1, or we can write n minus 1 factorial as n minus 1 into n minus 2 into n minus 3 factorial. Okay. Since n minus 1 factorial equals to n minus 1 into n minus 2 into n minus 3 factorial. So we'll replace the denominator by n minus 1 into n minus 2 into n minus 3 factorial. In this factorial we are having the number 3. N minus 3 we are having, right? So if we put n equals to 3, then only we'll get 0 factorial. So we'll start from n equals to 3. Okay. Fine. Plus summation 3 into n minus 1 by, for n equals to, okay, Here also you are having n minus 1 factorial. Since n minus 1 factorial equals to 1 into 2 into 3 into so on into n minus 2 into n minus 1. Also we have n minus 2 factorial equals to 1 into 2 into 3 into so on into n minus 2. Okay. So here we will replace this 1 into 2 into so on into n minus 2 by n minus 2 factorial. Since n minus 2 factorial equals to 1 into 2 into 3 into so on into n minus 2. Alright. So you will write it as n minus 1 factorial equals to n minus 1 into n minus 2 factorial. Okay. Since n minus 1 factorial equals to n minus 1 into n minus 2 factorial. So we'll replace this n minus 1 factorial by n minus 1 into n minus 2 factorial. Okay. So in this factorial we are having n minus 2. If we put 2, then only we'll get 0 when we put n equals to 2. See, 2 minus 2 factorial equals to 0 factorial. Okay. So the numbers which are less than 2, if you take for n equals to numbers less than 2, you'll have 0, okay, 1, 0, minus 1, minus 2. So for these you'll have negative factorial. In order to reduce the complexity, we'll take for or from n equals to 2 to infinity. Okay. Plus summation n equals to 1 to infinity 1 by n minus 1 factorial. Why we are writing? Here we wrote summation n equals to 1 to infinity. Since we are having n minus 1 factorial in the denominator, if you put n equals to 1, we'll get 0 factorial. So we start n from 1 to infinity. N from 1 in the third term and n from 2 in the second term and n from 3 in the third term. Okay. So this becomes summation n equals to 3 to infinity. Now cancel n minus 1, n minus 1, n minus 2, n minus 2, n minus 1, n minus 1. We'll get 1 by n minus 3 factorial plus summation n equals to 2 to infinity 3 by n minus 2 factorial plus summation n equals to 1 to infinity 1 by n minus 1 factorial. Here you're having constant 3, so you can take it outside the summation. The next step you can take it out. Okay. Now we'll write the first term for n equals to 3 to infinity. So this equals to 1 by, put n equals to 3. We'll be writing the first 3 terms, okay? For first 3 numbers, 3, 4, 5, and here you're having 2, right? 2, 3, 4, you're having 1. 1, 2, 3. We'll write for first 3. So now put n equals to 3, you'll get this plus 1 by, for n equals to 4, you'll get 4 minus 3 factorial plus 1 by the next number 5 minus 3 factorial plus so on. Okay, plus 3 into, we'll put 2, 1 by 2 minus 2 factorial plus 1 by the next number 3, 3 minus 2 factorial plus 1 by 4, 4 minus 2 factorial plus so on. Okay, plus for n equals to 1, 2, 3, 1 by 1 minus 1 factorial plus 1 by 2 minus 1 factorial plus 1 by 3 minus 1 factorial plus so on. Alright. We'll just write for first 3, okay? If you want, you can extend. So this equals to 1 by 3 minus 3 is 0 factorial plus 1 by 4 minus 3 1 factorial plus 1 by 5 minus 3 2 factorial plus so on plus 3 into 1 by 2 minus 2 0 factorial plus 1 by 3 minus 2 1 factorial plus 1 by 4 minus 2 2 factorial plus so on plus 1 by 0 1 minus 1 0 factorial plus 1 by 1 minus 1 0 factorial plus 1 by 2 minus 1 1 factorial plus 1 by 3 minus 1 is 2 factorial plus so on. Okay. Since 0 factorial equals to 1, and you could write this 1 by 0 factorial as 1 by 1, which is equals to 1. Okay, now we'll replace 1 by 0 factorial by 1. 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on plus 3 into 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on plus 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on. Since we know that e power x equals to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on. If you put x equals to 1, you'll get e power 1, which is e equals to 1 plus 1 by 1 factorial. 1 square is 1 by 2 factorial plus so on. Okay. See, here you are having 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on. Here also the same. So we'll replace this, all the three, with e. Since 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on equals to e. So we'll replace the first term by e plus 3 into e plus e. E plus 3 plus e is 5e. Okay. Therefore, the sum of the series 1 plus 2 square by 1 factorial plus 3 square by 2 factorial plus 4 square by 4 square by 3 factorial plus so on is equals to 5e. This completes the problem. So we have seen a problem from exponential series. Hope you will understand. We'll see you in the next video. Until then, bye bye.